Alright, so we're going to start. Are you sure that's the one?
Does it look like this?
No.
Oops.
I mean, sort of.
Oh, okay. I'll get it to you later. Yeah, I thought it was in the right folder, but apparently I wasn't. Okay, you can just delete that file.
Yeah.
Alright, so we're going to start with the engineering concepts sheet. If you're not doing something useful, please turn your monitor off or pay attention to me, because I need your attention. I don't know. Alright, so last week we talked about launchers. You guys remember that, right? And the week before that we talked about intakes. So what we're going to talk about this week is we're going to talk about arms. So in a lot of cases, when it comes to arms and shooters, they're somewhat mutually exclusive. So, well, let me back up. So when you're using an arm in FRC, essentially most games require that we take a game piece and we put it somewhere up high. Like, basically, in the last 8 years, 2017 is the only one where we didn't have to put a game piece up high. And even 2017 could be argued that we did have to put a game piece up high because we had to shoot the balls. The gear didn't have to be up high, but the balls had to be up high. So you know, game piece being up high is a really generic statement to make. But if you think about, this year, obviously we had to put cubes up in the top of the scale. Last year, we had to put balls up in the boiler. 2016, we had to shoot the boulders up into the tower. 2015, we had to stack totes. 2014, we had to launch that big ball up into a goal that was high above the ground. 2013, we were launching discs up into a goal that was high above the ground. 2012, we were launching basketballs that was in a goal high above the ground. In 2011, we were hanging tubes on pegs. So, and then 2010 was actually soccer, which was low to the ground, but that was a fairly unique game. But anyways, out of the last 8 years, there was some task in every game that required that we take a game piece from low down on the ground where the robot was and put it somewhere high. Now, obviously, with the way we build our robots, a lot of what we're allowed to do drives, what we're allowed to do through the rules drives the majority of our design. The game design committee specifically designs the rules to allow or disallow us from using certain types of mechanisms. Right? So last year, the rules were specific in FRC last year. The rules were specifically written so that robots could grab the game piece, lift it up, and deposit it in the goal. Right? In 2017, the year before, where we were launching balls, the rules were specifically designed not to allow you to pick up the ball and drop it in the goal. So my point is, if we're allowed to pick up a game piece and lift it somehow physically, that's a good way to do things. If we can't do that, we have to launch it. So in some ways, when we're talking about arms as a way, we're using arms as a way to move a game piece from somewhere typically low to the ground and raise it up high and deposit it somewhere where it needs to go, right? Shooter, a launcher, performs the same task. I'm actually Electra, would you shut the door but block it open? There's a class next to us and their door's open. So, but yeah, make sure you keep the blocks because otherwise the door will probably lock. So a launching device performs the same task, taking a game piece from down low and putting it up high. So it's good to keep in mind that when we're talking about arms, next week we're going to talk about elevators, but when we're talking about mechanisms like this, our objective is to take a game piece from relatively low and take it up somewhere high. So with one exception, which I'll get to in a minute, because there's always exceptions, always. All right, so if I got a robot, this is a drivetrain, this is side view. Typically, with a single joint arm, I'll explain a little bit more about that in a second. I'm going to have some sort of a tower, and I'm going to have a pivot at the top of the tower, and I'm going to have an arm, which is pretty much just a long stick, effectively, and it's going to have some sort of an end effector on it, right? Right, might be a gripper, could be a intake, could be, I mean, it could just be about anything. I mean, it could be a launcher. You put a launcher on the end of the arm. We'll get more to that in a second. So the reason this is called a single joint arm, a one joint arm, is guess what? Because it has one joint. This is the joint right here. So essentially, it can pivot down and it can pivot up, and that's about it. Okay, now this can look a variety of different ways depending on the application. The tower can be shorter, the tower can be taller, the arm can be short, the arm can be long. Essentially though, given the way rules typically work in FRC, the robot has to start at the beginning of the match fully inside of its frame perimeter. So basically everything has to be tucked inside of the drivetrain vertically. Right? So if I draw some dotted lines here that extend up from the drivetrain, you know, everything has to be inside. So essentially, the difficulty that causes with single joint arms is they have to be short enough that they can swing all the way down and get inside. Okay. Single joint arms. So I talked a little bit last week about linear mechanisms being more unstable than rotary mechanisms. Do you guys remember me talking about that? That's an important concept here. Arms are nearly always easier to build, simpler, and more robust if done correctly. If not done correctly, they're crappy. But if done correctly, arms are simpler and more robust than linear than a linear equivalent, which would be an elevator, which we're going to talk about next week. I mean, I don't have a good reason for why that is really, but linear motion just tends to be a more difficult thing to accomplish and a more inherently unstable kind of motion. It's hard to constrain something to move in a straight line perfectly. Things tend to want to rotate. So, a single joint arm is pretty much, when we're comparing major game piece translocation mechanisms, right? When you look at your robot, it's going to have all kinds of mechanisms on it, but there's going to be one core mechanism that's the mechanism that does the work to move a game piece from one place to the other, right? For most teams last year, that was an elevator that went up and down, and then something else could deposit the cube. That was the main game piece translocation device. Okay, in games where we're launching game pieces, that device is the shooter, right? It's the most important. I don't want to say most important, most central mechanism for putting the game piece where you want it. So out of those mechanisms, a single joint arm is going to be the simplest, the cheapest, the lightest, the most robust, right? If you can get away with using a single joint arm, do it. It's going to save you time. It's going to be simpler. You're going to have less trouble with it. Now, in a lot of games, out of those 8 games that I listed out of the previous years, there have only been a couple. There have only been a couple where you were allowed to lift the game piece up manually. We tend to launch more years than we don't. At least in the last 8, that kind of statistic drops off when you look at the last 4 years. But anyways, we typically are launching more than we're placing, just because it makes a better game if you're launching. It's just more exciting. So when you can use a single joint arm, you should. Well, I'll get more to that in a second. So let's give an example here. I have on the front of your sheet, I have this green robot. I got this green robot. This robot is 1503's robot from 2011. That year, the game was to take those big inner tubes and hang them on pegs that were like 10 feet in the air. Now this robot is one of the simplest, actually no, it's not one of, it's the simplest and simultaneously most successful robot in FRC history. It's not the most successful robot in FRC history. That would probably be 254's robot from this year, frankly. It's the only robot that's ever gone undefeated. But it's the simplest robot to be as decorated as it was. They won 2 regionals, maybe 3. They might have won 3 regionals, I don't remember. And they were semi-finalists on Einstein. That was back when only 12 teams made it to Einstein because they didn't have backup robots at championships, and there was only 1 championships. And they didn't do the round robin, so only 4 alliances made it. So they made it to Einstein with a championship setup where that was a bigger deal than it is now. So they were very good, and this robot had a drivetrain, it had a single joint arm, and a pneumatic cylinder to open and close the gripper, and that's it. That is all that robot was, no more. Now, okay, there actually was an endgame mechanism, but I'm not going to talk about that. Because everybody pretty much had the same endgame mechanism, so it wasn't kind of like what's particularly unique. But basically, the core robot was a pneumatic cylinder to open and close a gripper and a single joint arm, and they made it to Einstein. And coincidentally, this robot was the robot that won my very first regional as a student. So that's pretty cool. But anyways, so that's a good example of simplicity and how effective an arm can be if applied correctly. So let's talk about something a little more complicated. So the main drawback that a single joint arm has, let's talk about the example of an arm with a gripper at the end. Okay? So let's use the example that we talked about here where there's a tube, we're using an inner tube, right? And the tube is a ring, and you've got to put the ring on a peg. So if I'm holding the tube is like this, right? And the hole is going this way. Now my pegs are like this. And so if I move my arm like this, what problem do you guys see? Right. The hole is not facing the right direction. And that is, and so let's quantify this a little bit better. The problem with single joint arms is often that you don't have independent control of game piece orientation and game piece position. Does that make any sense at all? Okay, so I'm going to explain it. So if I'm rotating the arm, right, I'm lifting the game piece up in the air. If I'm rotating the arm down, the game piece is being lowered down, right? So I have control of the position of the game piece by moving the arm, right? That's fairly intuitive. But as you can imagine, as I'm doing that, the game piece is also rotating. And I can't change the orientation of the game piece at the same time as I'm moving it up or down. Okay, now in the case of this example, that was a drawback that they just chose to deal with, and they kind of went at it something like this, and I think they kind of, I don't remember exactly, but they kind of set the front of the tube on the peg, and then moved the arm down a little bit, which kind of like turned the tube in the gripper, and then they let go of it or something, and it kind of like swung down onto the peg. So they made it work, and it really didn't end up being an issue, didn't really slow them down a whole lot, but you know, that worked for this application. In some cases, that might not work at all, right? That just might not be an option. So that's the big drawback of single joint arms. So what do? Well, we need 2 axes of control, right? We need to be able to control game piece position and game piece orientation separately. So what do? We add a joint. Okay, to take this and add a joint, we get something like that. Two joint arm. This is a pretty typical configuration. This is what a lot of teams used elevators in 2011, but all of the teams that used arms, the team that I was on, the Mavericks included, this is what we did. Right? Basically, it gave you independent angular control of the game piece and positional control of the game piece. Now, typically, when you see two joint arms in FRC, typically this joint is really, really short. Right? This joint here is more analogous to a wrist rather than a elbow or a shoulder, right? Because rotating this doesn't move the game piece very much because this joint is not very long. Right? So this joint moves the game piece up and down a little bit, but that's not its main purpose. Its main purpose is angular control of the game piece. And then this joint here controls position. Okay? Obviously, two joints is more complicated, a lot heavier, a lot, less robust because there's more moving parts, but it has additional functionality. Now, typically, you will never see, I don't want to say never, but typically you won't see a three-joint arm in FRC. Right? You would almost never add another joint on the end of that. Because as you add joints, you get more and more weight, more and more complexity, and you get less and less returns every time you add a joint, right? So it's diminishing returns to the point where going beyond two joints is not usually worth it. Typically in FRC, we don't have to reach high enough that we ever have to do that. Now, if they ever throw a challenge at us where we have to reach like seriously high up in the air, like above 12 feet, you will probably start to see more three-joint arms. That being said, there are other mechanical solutions that allow you to get that high without actually individually driving joints. You can kind of gear joints together mechanically so that they extend at the same time, but I'm not going to go into that. That goes into more some complicated linkages and stuff, more like what 33 did this year, actually. So if you want to see some interesting linkages, 33 from FRC this year had some pretty cool stuff. Okay, let's talk about other arm styles here briefly, and then I want to go into something else. Obviously, I'm putting the arm at the top of the tower here, right? Why am I doing that? Why am I attaching the pivot point all the way up at the top of the robot?
Gives it more height.
Right, it gives it more height, right? So I can angle the arm down to get low to the ground, and then when I angle it up, I get the height of the tower. That's pretty typical. When you're using an arm, you're usually trying to get something high up in the air. Okay? We're going to talk about the exception to that here in a second, but in some cases, just because of geometrical constraints or something, you don't want to do that, right? Sometimes you don't want to attach it at the top of the tower. So you'll attach it down like on the drivetrain, right? You just have a pivot point like real low, and then you'll just have, two joints. The robots that do this tend to have two joints that are longer. This is a very uncommon thing, okay? The more common design here, and we're going to talk about it a little bit more next week, but I'm just going to mention it here for clarity. Typically, when teams do this, they have what's called a telescoping arm. So the arm is really a single joint arm, and then they have it extends. Okay, that's a pretty common design. It's very, 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 very mechanically complicated. I consider that telescoping mechanism, I consider that an elevator. I'm pretty much the only one that does, but we're going to talk about that type of a mechanism next week because I classify those two things as the same thing. So I would call this an elevator attached to an arm, just for the sake that I want to put it in a group, so I do. 971 had a really interesting robot this year. They had a pivot point at the back, and they had something like this, something like that, and then they had just a little gripper, and they went around and picked up two cubes that way. They had a couple little rollers at the front, kind of like we did, so that they could center the cube and their gripper would come down and pick it up. It was this crazy contraption. It looked super weird. If you get a chance, you need to look up a video of it because it's pretty crazy. Yes.
What was
971. Spartan Robotics. They won a regional or two. Like they're typically a very good team, but they kind of did this really complicated mechanism. It was pretty interesting. Yeah, it's one of the most unique robots I've ever seen in FRC. The picture on the back, this robot right here, this is my robot from my rookie year. So when my first year as a student, this was the robot. In the picture, it's kind of taken apart because I went back to their build shop a couple of years ago, and they had all the robots laying around, so I went around and took pictures of all of them, but all the electronics and stuff were stripped off of it, so the picture's not complete, but it's pretty good. Okay, before we switch tasks here, we're going to talk about one more thing. So, like I said earlier, arms in FRC are not very common. And the reason for that is, well, there's two reasons for that. First of all, most of the time, we're not allowed to lift things up high manually. Typically, the rules disallow us from doing that, and we have to launch them. You know, 2015, 2016, or not, 2016, 2017, sorry. We had to launch. We couldn't, our robot couldn't extend above a certain height. So that's a big reason. A lot of years we just can't. The other reason that you wouldn't go for an arm is that arms follow a circular path. Okay, and what this means is that as I lift a game piece up, it also gets farther away from the robot, right? As I swing up, I'm moving this way as well as moving this way. That makes them harder to drive. That makes them take up more space in this direction, which can be tough in a tight field. So that's a big disadvantage that arms have, so a lot of people end up choosing elevators over arms, especially now because there's a lot of off-the-shelf options for elevators. We're going to talk about that next week. Anyways, that's the big disadvantage to arms. That's why you don't see arms as much as you see other things. However, the big application that we do see arms for is actually for shooters. And this is a bit of an interesting one. Basically, when you're launching, you have to have an intake, right? You have to have some way of pulling in a game piece into your robot, right? That makes sense. You've got to get the game piece somehow. Typically, that's an intake that picks up off the floor, all right? In some cases, that's a chute or something that pulls something from the feeder station, but usually it's picking up off the floor. Somehow, you have to be able to pick up game pieces, pull them into your robot, and transition those game pieces into a state where they can be launched out of a launcher. Now, in some cases, like our 2016 robot, you can do that using a belt system. The problem with the belt systems is they can be a bit tricky to get right. They tend to weigh a lot, and they're tough to design, they're tough to tweak, and they're tough to tune. So what a lot of teams do is they combine an arm with a launcher. So essentially what they do is, in the simplest case, they have a pivot. Typically they have a small tower, right? So they have a small tower, they have a pivot, they have an arm, they have some wheels, right? They pull a game piece in. The simplest design of that, and probably the least common, is that they use their launch wheels in reverse to pull a game piece in. Then they raise the arm up, they reverse the wheels, and they spit the game piece out and it launches it. Okay, that's the simplest version of that. That's also, like I said, the least common, because typically your shooter wheels don't work as an intake wheels. They just don't. Right? They just typically, your shooter wheels are typically in a different position, in a different as like speed and everything, and that doesn't always work. Sometimes it works, doesn't usually work. Typically what you'll see is more of a design where you've got this big thing that's pivoting, and you've got an intake, and it pulls the game piece in, right? And it puts it in a position, maybe it moves it to the side or something, and then it launches it back out, right? So basically it pulls it in, shifts it somehow, and then launches it back out. Now, this might not seem any simpler than a belt system, and in some cases it's not. You typically still have to do some belt work, but typically putting this on a rotating mechanism simplifies your design somewhat. Not every case, but sometimes it does. The other thing it gets you is the arm gives you angle control over your shot, which is something that's not so easy to do with a launching robot that uses belts. Okay. The last picture on your sheet here is 33's robot from 2013, and they used exactly that system. The little thing that's up at the top that's kind of folded back, that's their intake, or one of their intake rollers. And this was the year where we were picking up and launching Frisbees. So this whole arm here would rotate down, their intake would flip down, they would pull discs in, then the whole thing would raise up and they could shoot. And they had angle control of their shot because the whole thing was mounted to an arm. And then the other nice thing about that is they had this big heavy mechanism that was rotating around, had a lot of power in that arm. So what they were able to do is that year we had to lift ourselves off the ground just a couple inches, but we just had to get our robot so it was not touching the floor anymore off of the bar. And actually the bar is shown in your picture. And so what they just did was they just put a couple hooks on their main shooter mechanism. So they would just raise their arm up, hook onto the bar, and just raise their arm down, and it would pick their robot off the ground. So they didn't have to build a separate subsystem to lift their robot off the ground. They just used an existing mechanism. So when you've got an arm, you can use it for other things that it wasn't intended for really easily. If you have an elevator or a belt system, that's not a multi-purpose mechanism. It's harder to use that for things. But an arm, you can kind of use it for whatever you want. So arms are great. They don't get used nearly as much as they should. Elevators, in my opinion, get used. I mean, elevators are great. Everybody likes elevators, but elevators get used more than they should. No, don't give me that look. I don't want to hear it. All right. So, any questions about arms? Nothing there's anything bad about elevators except our elevator. Gotta be the worst elevator. All right, so next we're going to talk about off-the-shelf stuff. I should erase this. All right, so you guys remember what a drivetrain is, right? No. We talked about that like the first or second week. So when we're making a drivetrain, do we just drive our wheels directly off of a motor? Yes, because we'll break the speed of light if we do that. No. Typically, your motors are way too fast to drive a robot directly. You've got to slow them down. You've got to use, you guessed it, a gearbox. Okay. However, on FRC robots, typically we're not using just one motor to drive the drivetrain. Most robots are tank drives, so you're driving one side separately, you're driving the other side separately. However, if we were just using one motor for each side, we could use like a versaplanetary or something, right? We could use a gearbox like we worked with on that drum roller project. Okay, but nobody's doing that. Your robot would be way underpowered. Everybody on the field would be able to push you around. You wouldn't be able to accelerate very fast. So everybody uses more than one motor on each side of their drivetrain. Okay, so that presents kind of a weird issue. We have to take more than one motor and gear them together so that they're all running the same thing, and then we have to drive our wheels with that. Well, as you might expect, there's an off-the-shelf solution for this. There's a lot of off-the-shelf solutions for this. That is not. Okay, so gearboxes do two things, right? Obviously, they do what all gearboxes do, and they slow your motor down. There are a couple gearboxes that speed motors up, but typically you don't want to. So they slow the motor down and they give you torque, right? So you're trading angular velocity for torque. In addition to that, they also combine the power from 3 different motors or 2 different motors, and they combine it into one output shaft, basically. So you've got multiple motors driving one output shaft. Now, there are 2 types of drive gearboxes. There are single speed transmissions, right, which is like the gearbox that we designed a few weeks ago. That thing that had the 2 plates. You guys all finished that project?
Yes.
All right. If you haven't finished that project, you should finish that project. Because we're going to, during the season, we're going to design stuff that's pretty much exactly like that. So get that done. So that was a single speed transmission. Now that only used 1 motor, but it could be adapted pretty easily to have 2 motors. And that's what single speed drive gearboxes are. The other type are 2-speed gearboxes. 2-speed gearboxes have a shifter. And basically what the shifter allows you to do is it allows you to change your gear ratio. Most FRC gearboxes are 2-speed. There aren't, as far as I know, any 3-speed gearboxes in FRC. I think a team or 2 has built one every once in a while, but it's not very common. On a car, you know, cars have multi-speed transmission. They have 5 or 6 speeds typically. And that allows them to change their gear ratio as the car accelerates so they can keep the engine running at a specific RPM or a range of RPMs where the engine's producing the most power. FRC's kind of the same way, right? We want to maximize our torque when we're accelerating or pushing somebody. So when we're going low speed, we want to get as much torque as we can have so we can accelerate quickly or push people around. But then we also want to be able to go fast, so we need a higher gear ratio to allow us to go fast. So typically you've got 2 speeds. You can change your gear ratio using a mechanical device, and that's why you would use a 2-speed gearbox. So let's talk about a few different gearboxes that we can just buy off the shelf. Now, off-the-shelf gearboxes are expensive. They're typically, because there's such a huge range of varieties of drivetrains and different teams want to go different speeds, it's hard to use off-the-shelf gearboxes. A lot of teams do it because they don't have the expertise, the experience, or the machining resources to be able to make their own gearboxes. We nearly always make our own gearboxes. For the past 3 years, we made our own gearboxes. We make our own shifters. So we've been using 2-speed transmissions. We may try to get away from that this next year, depending on what the game is, just because it's kind of hurting us for complexity, and we need to cut down and simplify. We may try to go for a single-speed transmission this year, but we'll see what the game is. We should have done a single-speed transmission this past season, like hands down. Actually, we might have actually got picked.
No, our elevator was too bad.
Well, that's a separate discussion. All right, so let's look at single-speed gearboxes. The biggest one here from Andy Mark, there's all kinds. There's the 3Sim4U, the Tough Box. If you just go to Andy Mark, go to Gearboxes, and go to single-speed gearboxes, there's a whole bunch. These 5 here at the beginning, these are all for drivetrains. These other ones down here, well, this one's for drivetrains too. These other ones down here though are not for drivetrains. They only have one input motor, so you can only drive one motor with it. This gearbox and these 5 up here are for drive gearboxes. So this one here, all of them are made for the sim motor with the exception of this gearbox right here. So this gearbox is called the Tough Box Mini. This is the Tough Box right here. Tough Box was, you guys know about the kit bot, right?
Yeah.
So a lot of teams use that drivetrain. This used to be, Andy Mark makes the kit bot drivetrain. And so this was the gearbox that was used for a long time, the Tough Box. It's heavy and obnoxious. And everybody uses it. In my opinion, it's poorly designed. It weighs way too much. It's just it's a clunky thing. Like, I mean, it just weighs a ton, and there's no reason that it needs to weigh that much. So they developed the Tough Box Mini, which has a plastic housing and thin plates, and it's just a much better design. This is what's used on the kit bot now. It's pretty good. I believe it comes in, I think you can get it in a hex output. Yeah, you can get a hex output shaft for it, as well as round, which I guess is default. I don't know why. Andy Mark has weird gearbox designs. If I have a choice, I don't use Andy Mark gearboxes because they're just not. Yeah, I have a lot of complaints about their design styles, but yeah. But this is a good one. This is what most teams are going to use on their drivetrain because this is what comes in the kit bot. In addition to that, Vex has a bunch of products. They have 2 big ones. So there's this one, and if I can scroll, my mouse is freaking out here. So this here is a gearbox from Vex Pro. It's got a hex output shaft, and it takes 2 sims as an input. So you'd use one of these on either side of your drivetrain. So 4 sims on your drivetrain total. This is cheap. Not that expensive. It has a few different gear ratio options. You want to use gear ratios because if you use different size wheels or you want your drivetrain to drive at different speeds depending on what the game is, you want to be able to select your gear ratios. So nearly all these gearboxes I'm going to show, actually all of these gearboxes I'm going to show you, have a customizable gear ratio. You can buy different gears and swap gears in and out so they have different gear ratios. Now, this gearbox here doesn't have a lot of gear ratios. It only has, I think, 3. But it's plastic, which means it's light. It also means it's not as strong. But it's a very small gearbox. It's good for just keeping it simple and keeping weight out of your design. I've never used them. It's not very commonly used. Outside of the kitbot drivetrain, most teams use 2-speed gearboxes. The last single-speed gearbox we're going to look at here is this one. This is developed by a company called West Coast Products. The big advantage of this is that it can mount 3 sims, which is slightly more typical in modern first, because we're allowed to use more motors, so teams use a lot more motors in their drivetrains. So it's a lot more typical to see 3 sims. This is a really good 3-sim gearbox. It's very light, obviously has lightning holes in the plates and everything. West Coast Products is a different company, but Vex pretty much distributes all their stuff. I mean, West Coast Products sells stuff themselves, but they sell pretty much all the same stuff that Vex does. So they're partnered. I don't know how that exactly works, but Vex Pro and West Coast Products sell a lot of each other's parts, so it's kind of just they're partnered. Vex Pro's in Texas, so they're closer, so we usually buy from them. Okay, so this is the last single-speed gearbox we're going to use. So now we're going to look at 2-speed gearboxes. Now, most robots, especially now, because there's so many different 2-speed gearbox options, you can just buy them. A lot of teams use 2-speed gearboxes. So it used to be that 2-speed gearboxes were fairly uncommon. Andy Mark, I think, came out with the first two-speed gearboxes, and this might actually be it. This might be the first two-speed gearbox that was made for FRC use. I'm not 100% sure about that. What did I just say? Anyways, I never used that. The big Andy Mark's big product is now. This came out last year or the year before. It's called the Evo shifter. You can buy them for 2 sims. You can buy them for 3 sims. They have a hex output shaft. They have a huge range of different speeds. You can also buy a version of this for the 775 Pro motor or the red line, which is occasionally being used in drivetrains. You guys remember when we talked about the red line 775 Pro motor versus the sim motor used for drivetrains? You guys remember that? How the red line is more powerful and a lot lighter and smaller, but the sim burns out less easily. The red line burns out pretty easily, but the 775 Pro and the red line are the same thing. So they also have a gearbox, a version of the Evo shifter that works for the red line motor, which some teams are using. The nice thing about the Evo shifter for most teams is that this can be, you can take, if you buy the kit, or if you have the kit pot, right, it comes in the kit of parts, you can take off the gearboxes that are on the kit pot and just bolt one of these in place, right? So a lot of teams using a kit pot, they buy a couple of these and they just drop them in. So the kit pot, they can use the kit pot, but they have shifters, okay? Typically though, this caught on a lot last year, like a lot of teams used these last year. I'm pretty sure it was new last year. Andy Mark does have a couple other shifters. They have the Sonic shifter. I guess they just have the Supersonic shifter, which is built more like a tough box, i.e. way heavier than it needs to be. Andy Mark. We used, in 2014, my senior year as a student, we used a couple of Sonic shifters, not the Supersonic shifters. We used the Sonic shifters. I mean, they were okay, but they made a big change to the kit bot that year, and sucked, and we paid for it. Like it was undrivable. Like it was so bad. But anyways, all right. So Vex also has a bunch of 2-speed transmissions. Their most popular one is what's called the ball shifter. There's 2 varieties. There's this one, which is the 2-sim ball shifter, which has 2 motors on it, and the 3-sim ball shifter, which has 3 motors on it. They call it a ball shifter because it uses a pretty unique shifting mechanism, and it uses ball bearings, like round metal spheres, and it uses those to lock in the different gear ratios. I'll explain what the typical mechanism for shifting is, but the ball shifter uses a different mechanism, and it's pretty good. It shifts really smoothly. It's smaller and lighter, takes up less space. It's a really good mechanism. A lot of teams use this gearbox. I've never used the ball shifter itself with the plastic housing. I know the plastic housing is kind of an issue because it's weaker, but it is also a lot lighter than Andy Mark's products, especially like the Sonic shifter. But it can break if you're not careful with how you design things around it. The nice thing about the ball shifter is though that Vex sells the ball shifting mechanism, like just the shaft that does the shifting. They sell that separately. And so that we buy that shaft, and that's the most important part of the gearbox, right? Figuring out the gear ratios, putting the gears in there, making all the cluster shafts, making the end plates are pretty similar to this project, right? When we worked on this gearbox project, like I walked you through pretty much everything you need to know to design a gearbox. It's just the shifting mechanism itself that's hard to build. So on Stellar, we just buy the ball shifting shaft and then design the rest of the gearbox around it to do exactly what we want. So that's what's really nice about the ball shifter. We're using the ball shifting mechanism in all our gearboxes. We're just not using the ball shifter housing because we can do a better job figuring out exactly the gear ratios we want, designing the gearbox to fit in our robot. So we're kind of using the ball shifter, but we're not actually using the ball shifter. In addition to that, West Coast Products also has a gearbox called the DS gearbox, which as far as I know stands for dog shifter, and that has to do with the mechanism that's used to shift gears. So they use what's called a dog gear, which is effectively just let me show you. So these are dog gears. So essentially they've got these like teeth on the side, right? There's kind of a ring and they've got these teeth on the side, and that thing shifts back and forth, and basically the teeth on one side will engage with one gear, or you shift it back the other way, it'll engage with a gear behind it. So this is what's called a dog, or a dog gear, and this is what's used to shift in the West Coast Products dog shifter. This gearbox and this configuration that's right here is pretty much a direct copy of the gearboxes that 254 uses. West Coast Products is, I don't know, they're from California somewhere. They're founded by people that were involved in 254. I don't know the details of exactly how that worked out, but 250, in terms of their drive gearboxes, all their drive gearboxes are designed off of stuff that 254 does. So, that's what this is designed off of. They also sell a 3-sim variety like this, and it's also got an option for a PTO, which we're not going to talk about here, but it's a thing. It is a thing. So these are really good. They're really light. They're a lot stronger than the ball shifters because they obviously don't have the plastic housing. They are somewhat heavier, but they're just really, really well designed gearboxes. They're pretty expensive, but a lot of teams use these as well, especially out west. The Evo shifter, which is Andy Mark's thing that I talked about, this guy, the Evo shifter also uses a dog gear. You can see in here the gears have these teeth on the side and the dog's in between. You can't really see the dog, but it shifts back and forth and engages different gears. So this year, this year we're going to design our own gearboxes for our drivetrain again. I'm sure I don't see any reason why we won't. We're going to try to do single speed. If we don't do single speed, I'll show you guys how to go through the process of designing a 2-speed gearboxes when we get to the season. It's pretty complicated, but it's not that hard. It takes a lot of work. So, any questions about shifters or drive gearboxes? No. Okay. We're going to move on to CAD. Now, bear in mind that before we do that, real quick, let me take attendance. I'm going to just call out names probably here. So just say here, nice and loud when I call out your name. Once my phone loads. Come on. Get it together. So tonight we're gonna be doing a lot of stuff. We're not gonna be working on a project. We're gonna be working on learning some stuff in Inventor again. I'll be with you in a second. So alright, Ben Crouch. Caleb, not here. Coulter's not here. Dale, you're here, right?
Yep.
Electra, you're here, right?
Yeah.
Elliot?
Here.
Gavin? Jimmy?
I'm not here either.
Right? Luke,
I prefer Luce.
Max,
Yep.
Mike, Olivia, who's that?
Who is she?
Oh no, I don't know everybody. Yeah, it's okay. Okay, so I don't have any helpers. So when you guys are working on something, I expect your screen to look like mine does, right? If your screen doesn't look like mine does, or something's not working the way that I did it and I'm going too fast or something, I need you guys to stop me. Don't just sit there clicking on your computer trying to figure it out. Ask me for help. I can't see your screens, so it's up to you, for you guys to determine whether you need help or not. There's nothing wrong with asking me for help, but I'm just gonna keep going unless you guys need help. So if you guys need me to slow down, ask me to repeat something, I will repeat it. If you guys need me to get up and look at your screen because something weird's going on, get my attention. Don't just sit there, because I don't have people watching your screen, so I'm gonna need you guys to help me manage my time here. Okay, this file up on my screen, how many of you guys have done it?
I did it, but it was in 2018.
Well, that's fine, you're working on 2019. If you don't wanna screw up your files, if you still wanna be able to open 2018, okay, let me back up. We're using 2019 here. If you save any files that you work on at home in 2019, you won't be able to open them at home until you update to 2019. Now, everything that we're gonna be doing in the upcoming season is gonna be in 2019. So if you guys haven't updated to 2019, you should update to 2019.
I found a flashlight.
You got your flash drive? Okay, did you do this project? Okay. Yes, right, so update to 2019 if you can, just go and download it from Autodesk, install it just like you did in 2018, and then just uninstall 2018 from your computer. But yeah, just keep in mind if you save something here, you won't be able to open it. Luke, if you want to be able to open it at home, just make a copy, just copy and paste it into the folder and name it something else.
Okay. Well, I'm gonna update.
You're gonna update, okay. Yeah, I'm in the process of updating all my computers, I've got 5 I have to do.
You have 5 computers.
I don't, but I've got the FRC computers that I'm doing too, and the FTC. Actually, no, I got 6. I have 6. I got 2 of them. All right, so who does not have this file? I don't know. It's the end plate from the Gearbox. So.
Yeah, that one. Well, that one's colored, but it'll work.
I probably don't
You probably don't. Okay. Whoever does not have it, go ahead and bring your flash drive up to my computer, and I'll just copy it.
It's in the wrong seat.
Didn't bring that right
That's a very.
Luke,
Yeah?
I'll come to you. Leave your.
I already have. Yeah, I do.
Next. If you want me to correct it.
Or I'm gonna make it clone.
Just SC18. W6.
Wow, look at that. Let me make mine clone.
Had a tiny little
I don't really wish I knew where it went.
Oh, it's only on my USB on the other side.
Oh, I see. Is it USB-C or just?
Asphalt, or asphalt, or whatever.
Luke, you said you did have it?
Yeah, I do have it.
Okay, alright.
This Is that the finished product?
This is the finished product.
Yeah, but I need.
I was gonna say our gearbox from last year looked the same as one of like, I think Texas. Or very similar.
I
Our drive gearbox?
Yeah.
Yeah, our drive gearbox is last.
Yeah, that one, I think.
Looked more like this,
Yeah.
except we had 3 motors, we just added one on the side.
I
And that's
thought we
not,
added it on the top.
no, that was 2 years ago.
Yeah.
Was that what you meant?
That's what, I meant last year, but.
Yeah, our
I don't know.
gearbox from M54 looked pretty much exactly like this.
Yeah.
And that's not a coincidence, I mean, we model them off of, we model our gearboxes off of this kind of design style. The only difference was, the motors were actually on the opposite side.
Yeah.
So the motors were on this side, where the outlet shaft was.
And then we used those gear shifters, right?
Ball, no, this is a dog shifter, so we actually use the ball shifter, which is for this gearbox. Okay, everybody has that plate then, right?
I thought you were.
You still need, you wanna bring your flash drive? Oh, you don't have your flash drive, right?
Am I, how did that feel about you?
Okay, you're gonna have to move to a different computer.
Okay.
Which computer do you wanna use?
You know, like just
You can do, I mean, you don't need to keep your files from tonight, but then you get. Okay. You told me that you didn't have your flash drive, and I was like, why is he telling me he doesn't have my flash drive? Now I figured out what you meant. It's like, why did you don't have, okay, cool.
He's saying he doesn't have a flash drive.
Well, he was saying that I was gonna have to come put it on his.
Oh, this one's not.
I stand for iodine.
Okay.
This one's not working. It's not working.
Oh, really? What's the matter with it?
No.
Okay, here's what we're gonna do today, guys. We're gonna show you guys how to create a drawing, like a schematic, or something like that. Now, why do we create drawings? Does anybody know?
So you can print it off,
Okay, but why would we wanna print it off?
so that you can make it.
Right, so that you can make it. So who uses a print or a drawing? Who uses it?
A tool and die person.
A machinist, right? Somebody who's machining your part, they'll make parts based off print. So, can we model our whole robot and not make any prints for it? Or, I keep calling them prints, drawings.
Yes, we can, but we don't want to.
Well, okay, alright, that's fair. Technically you could, but, no, so basically you've gotta be able to communicate the design of your parts to somebody who can make them, to a fabricator. So, we don't do a lot of these, but we do some. So, what we're gonna do is we're gonna go up to new. We're gonna go down here to our 3rd row. So we've used parts, we've used sheet metal and standard parts, we've used standard assemblies. Now we're gonna use standard.idw. Now look at the icon on my screen, click on the one that I'm clicking on. Not this one, click on this one. Standard.idw, not standard.dwg. Okay, so click on that, click create.
I'm scared.
So essentially what we're gonna do here is we're gonna take a part, you can create drawings for parts and assemblies, and you can, I realize you guys are gonna need an assembly. Alright, well, I'll show you guys how to do this. Okay, so this piece of paper is not the right size.
Okay.
We don't want our piece of paper to be this size. So if we go over to sheet 1 over here in the browser and we right click on it, hit edit sheet. Okay, everybody got this dialog?
I was looking at that, I got that.
IW, yeah, that's right. And you're gonna need that gearbox. I'm gonna give you 1 second, guys. I gotta transfer files real quick.
They're running 400,000.
Oh my gosh. Gearbox. Actually, just right there. Gearbox. Yeah, just copy. Yeah, the whole folder goes on. You're gonna need the whole assembly. Okay. Who does not have the whole gearbox assembly? I gave you guys 1 plate, but I realized I intended us to do the whole thing, full assembly.
I got part of it.
Part of it's fine. If you have part of it,
I got like 3 parts. I didn't do the screws.
that's fine. That's fine. You're good then. So Dale, you need it?
Yeah.
Didn't you say you had all that?
I didn't do the screws. I didn't watch the last video. Oh, I said I didn't do it. Good. Wait, some other-
Oh. How big is this?
I was just looking
And
at
if you have gearbox?
his machine based.
Wait.
See, mine works with that dirt stuff. That's just how the
My gosh.
Actually, it's not sure. It's a lot straight. I'm not sure.
Oh, there it goes.
Oh, that's weird.
Oh, the one thing that I don't think it's enough.
It's Google.
Who else needs the whole gearbox assembly?
I need those.
Like I said, if you have it partially finished, that's fine. You just need.
I need the entire.
You did the entire thing. You two, well, I gave it to you. You have it.
Yeah.
Good.
Got it.
Good.
Except for mine's
Down
like aluminum 66 one. It's blue.
It's fine. The color doesn't matter. Kelsey, you have the assembly?
That one.
Laser cutting.
gearbox and put it in, and you're gonna do mold and group it together. It's a lot.
Alright. Okay, so back to what we were doing. Let me get back to where we were. Alright, so sheet 1, edit, no, sheet 1, edit sheet. Okay, under size, click the drop down list. Drawing sizes are lettered. So A is a normal 8.5 by 11 piece of paper. Okay? B is 2 A's put together like this. Okay, that's a B size. It's 11 by 17. And then a C size is 2 B sizes put together. Rotate and put them together. So basically, C ends up being double the size of an A. Okay. We always print on A sizes. Sometimes we'll use a C size and we'll scale it down to fit. I'm not going to go into that, but basically we're always using A size. So click on A and then click OK. Now this is a border, right? So this weird kind of thing with the arrows and the numbers, this is called the border. This block right here, it's got all these words and stuff in it, this is called the title block. The title block is a very important part of drawings. Okay? We're going to get into that a little later. For Stellar Robotics, the title block's not so important, so I'm not going to really go into a ton of detail, but we'll talk about it briefly. So, but the bottom line is this title block's meant for a bigger drawing. We need to put a little smaller title block in here so we have more room on our page. So over here under sheet 1, under ANSI large, right click and delete. All right, the title block should disappear. Now if we go up to drawing resources, right where my mouse is up here, this little folder says drawing resources in the browser. Expand it. Go to title blocks and expand that. Everybody good? Right click on ANSI A and hit insert. Click on insert and the title block should appear in your drawing. And it's a little bit smaller. It's still pretty big, but it's a little bit smaller. Okay, so now we have to find a draw, or we have to put views in this. Okay, so basically, you know, we want to put in like a front view, we want to put a side view, top view, you know, whatever views that we want to put in the drawing. We have to do that now, basically, and then we can go and do our annotation later, which we'll get to in a minute. So we're going to create what's called a base view, and then we're going to create what's called projected views off of that. We'll get to that in a second. So under here, under the Place Views tab on the ribbon, we're going to click Base, which is this first button right here. It says Base. Click on that. So now we've got to go find, we have to go find a file. Now the file can be a part or assembly. And we want to find the part or assembly that we want to make this drawing of. So click on this little browse button, the little folder button right here where my mouse is. Click on that. Now, I gave all of you guys a folder called Completed Gearbox. I want you guys to select this assembly. It's called SC18_W6_ASSY, which is short for assembly.
Say that again.
SC18_W6_ASSY. Okay, once you guys click that, for those of you who finished your Gearbox projects, good for you, first of all. Second of all, find wherever your assembly is, whatever it's called, and select it. Now click Open, yes? Look at the
icons, yeah, the icon's different. Just click, okay, just click open. Yeah, just click open and you have to do a whole bunch of things. Open, that's good. Yeah. So don't.
Yeah.
That's not the one that was,
You guys, how many of you guys have a dialogue that comes up asking you to open a file?
we wanna put the gear.
Should I open it? Do I open it?
I think I screwed something up. Yeah, if you click open.
It's motorcycle guy.
Open. You're good. Yeah, so just.
Feels all powerful. You cannot get rid of motorcycle.
Okay. I screwed up and didn't give you guys all the files. You're looking for the file.
Yeah.
Okay, so it's gonna be under. This is your. Right. And then scroll down. If you guys are getting a message that has open, skip all, just click skip. So scroll down all the way down. If the icon's different, so see the one that's blue? Yeah, that's the assembly. So click open. And then click skip. For some reason, I guess I didn't put the motor in that folder. Ben, you got it? Good? Okay. Okay, do it again.
Good. Wait, what is that?
Okay.
We don't learn any elements. What is each thing?
Dale, you're going to delete that out, do that again. Just leave it there.
He took a picture of me in the best streets. He's like,
It's showing up a little weird, but we'll cross that bridge when we come up. All right, it looks like everybody's in the same place. So, let me get there. Okay, so we've got. Don't click or do anything here. If you did click, you just hit escape. Delete anything that's in the. You can click on the view and delete it, and then do that again. Okay. All right. So this creates a view. This is the base view right here. You've got a view cube that you can use to rotate. To go to different views. We can go to a top view. We can go to an isometric view. Okay. We want I think we want a right view like this. Now, you can click and drag on the view to move it around. You can change the scale in this dialog box. When it says scale, you can type in the scale that you want. If you wanted to make it a little bigger, right? It should change in size. Now you're not going to want it very big. You're going to want it about the size I have it on my screen. And you're going to want to position it kind of over here to the side. That'll make it easier. Yes, Alexa?
Mine is just the plate, not the actual gearbox.
Oh, just like those.
Oh, okay. So you actually just select the plate.
Hit that little search button on the right of it, hit this. Hit that. And then scroll around and find the gearbox. If you go to the top and you select large icons, it'll show you a picture. Right. Yes.
Which one's your?
Yeah.
This shouldn't be happening, but it is. It's just, I didn't give you the motor file, it's freaking out, I can't find it. It should be able to, it should be okay. Alright. So you can, yeah. Alright, everybody got?
He doesn't. Question.
Mine won't even let me open it.
I think you probably have the same problem. Everybody else is having.
I felt that.
What do you do for 775 Pro, Brian?
What?
How do you get rid of the motor thing?
Just open the assembly, hit skip, and then just delete the motor. It'll show up gray in the browser, just delete the part out of there.
It gives an error.
I know, it's okay.
And then do what?
Go, you got the assembly open, right? Just delete the motor out of there. That's all you can do right now.
Show the assembly.
Alright, so now you should go.
Oh.
So,
What is this? Why is it like this?
there's a skybox that acts as a reflection. You good, Ben? Did you open the assembly? It's under complete gearbox. Just scroll up to the folder.
Oh,
No, scroll up. Complete gearbox, the first one. Scroll down.
Oh, there.
Yep. So see the gray part. So basically, I didn't give you the motor file. So just
All of this is random.
just right click, delete, save it. Just click OK. Okay. All right, now you should go place it. All right, so let's talk a little bit about what happened there. Yes.
What's wrong?
Oh, you just changed your title lockout.
What do you
Cancel. Delete cancel large.
Wait.
I didn't even read your.
Wait.
And then go up to NCA and right click insert.
All F4.
Now you can place the glue back in there.
Not working, do all F4.
Alright, so basically what happened there, guys, is that I gave you the Gearbox file, but I guess I stored my 775 Pro model in a different folder, and so when I copied it to your guys' computers, the motor that's in that Gearbox, that file was not on your computer. So Inventor was giving you an error saying, I don't know where this file is, and it was asking you to find that file. That's what that dialog was that had the skip button on it. It was asking you to find a file that it couldn't find. Now, if you guys had that motor file on your computer and it was somewhere else, you could have used that file. I think Jimmy had that file. So like I was able to just tell Inventor, go here, and it was okay. For those of you who didn't have that file, You just had to go into the assembly and delete the file out so Inventor would stop looking for it. So that was our problem there. We should be good now. So we don't have a lot of time. We got a lot of stuff to get through. So let's forge forward. Okay. So we've got a base view here right in the middle. You guys see this green box that's kind of going around? If I click, don't click yet, but if I click, it will place a projected view. Basically, a projected view is a view that's like rotated 90 degrees. So if I like go up to the top here, I could click and it would place a top view. So go ahead and do that. Right? And you can place a side view, you can place a bottom view. If you go up into like the right or the left or down into the right, it'll place like an isometric view, which is kind of at an angle. We're not going to do that. I just want a side view and a top view like this. If you create a view,
How do you get rid of the
we create a view over here, Ben. I'll show you. You see this little X? It's this little X, just click on the X and it'll remove the view. So if you create extra views, there's a little X, just click the X and it'll get rid of it. Alright, does everybody's screen look like mine? Alright, so you guys see these three buttons right here?
Yes, I do see the 3 buttons.
Everybody see these 3 buttons?
Yep.
Alright, so we can create, click on the middle one, make sure the middle one's selected. If you select one button, it'll deselect the other 2. So you're making choices. Actually, no, that's not true. These two buttons, you can select between these 2 buttons. And this button, you can push it in or unpush it. So if I click it in, it stays pressed in. If I click it again, it pops back out. All right, so select the middle one and make sure this end one is not pressed in. Click OK.
Oh, which one's not?
The one on the right.
Oh, okay.
All right, click OK.
Oh, who's on the top?
All right, does anybody's screen look like mine?
No.
Are you having trouble, Ben?
Oh,
You getting it
why
figured out?
no?
Did you figure out how to delete your views?
Oh, yeah.
Oh,
No, I did
Did you figure out how to do it?
It's not in the exact same position.
I mean, it's fine. You guys can click and drag on these after.
Also, it's just black.
I don't think I did.
It doesn't show as much of the detail yours does.
Yes.
Hard to draw.
Did you see the other kick I sent you?
So click. Actually, just double click. Click where the dotted line is. See how your cursor changes? Double click. See if you're in here, you need to uncheck this spot.
There we go.
And these green lines will go away eventually. That means it's moving. So until those green corners go away, it won't look exactly like mine, but it's close.
How can you keep your streak big?
Okay, so if you want to change the scale, you can double click. You gotta double click and then go to.
It's not perfect.
You can drag those around. Okay, looking good. All right, guys. So if you double click on one of these views, the base view, it'll pull this dialog back up. Does everybody have the dialog box on their screen?
No.
Double click, guys.
Double click on the picture.
On the just double click on it.
Okay.
Good.
I'm good now.
Good. Okay. All right. So these 3 buttons here, these change the visual style. So let's see what happens if we press in this right one that says shaded. Yes.
The buttons roll grayed out for me.
Oh, you clicked on this. You need to click on the bottom. You can. You okay to do that? So just double click on this. Oh, no, you're fine. Oh, yours is loading for some reason. I don't know. Your computer's doesn't start. Yeah. That's a weird code. I really can't. There's really nothing I can do to change that. It's just gonna take a bit to load. So. Alright, so if we press in this button here that says shaded, and then click OK, what happens?
Look at the color.
Right, it has color, it has shaded. It's not just lines anymore. Now, in the case of a print, a drawing like we're working on, this is typically not a great idea. Uses a bunch of ink. It's hard to see what's going on because everything's filled in. Lines are typically better, but sometimes you want to put like an isometric view up in the corner just to show a visual representation of the part. That's what you use shaded for. So, turn shaded back off and click OK. Alright, now let's mess with the other setting. So double click on the base view again, and click on this button over here. It says hidden lines. Click on that and click OK.
What?
Wait, click on what?
This button here.
Oh, okay. Yeah, I already did
Oh, you
that.
did base again?
So basically what this does is it shows lines through other lines. So like I can see my screws inside of my standoffs, everything's kind of these weird dotted lines.
Don't click shaded and that one, because then it just.
Oh yeah, that's what I did.
See what I want. Alright, but we want the middle one and we don't want it shaded. So change those back to the way they were. Take it back to this.
What's the wrong spell?
Yes.
I've actually been watching just release videos.
Oh, reveal videos? Yeah.
I saw 33 and started to buy it.
Is it like from this year?
No, from the ones on the sheet.
Oh. That's a good way to save a lot of time watching release videos.
Yep.
Get into those in a couple hours you're gone, you're like, oh.
With this dual monitor setup, I can watch Fume and I can watch release videos.
At the same time. Okay, alright, so we've got a view, right? Now we want to show some dimensions, right? Basically, on drawings, typically have dimensions, right? You guys ever seen a plan, like a
Yeah.
floor plan for a house?
Yeah.
They have dimensions, right? We want to put those on. So, it works just like a sketch, right? Placing dimensions works just like a sketch. You can place linear dimensions, like for the length of things. You can place dimensions between parallel lines. You can place dimensions for the diameter of circles or the radius of arcs. You can place dimensions that are the angles between lines. Okay? So, do you have a question, Ben?
It's important.
We're going to talk about that in a little bit. Alright, so go to the Annotate tab on the ribbon here. We've got 30 minutes. We got a decent amount to get through, so let's do this.
Oh. Thanks, Liz.
Alright, so click on Dimension. Let's dimension the depth of the gearbox. So click on this line here and this line here.
This.
Okay, this works just like a sketch, and then place the dimension up above. Now this dialog box is going to come up. You need to go to the middle tab. Actually, everybody got this dialog box?
Yes.
Yeah.
The outside?
The two outside. See the one lines that are red? I guess.
Scrolling. This one
Does anybody not have this gearbox or this?
and
It's
this one.
7:30. It's past my bedtime.
That should be it.
Does anybody not have this dialog box?
What?
Everybody got this dialog box now?
No.
Okay.
It's your-
Gavin, you see the two lines that are red on my screen?
Yep.
Those are the two you'll select.
They're not red on the main screen. Actually, they're fairly good.
Yeah, something was going on with the projector when I walked in. It was like twitching and like changing colors. I think the bulb must be dying. I mean, this projector's been in the league forever. Alright, everybody got this dialog box now?
Check there's something in my group.
Mine says 1.63.
Dude.
It
Right.
like has like a space.
That's just from the outside
Oh,
yeah.
Okay, go to the middle tab on this dialog box. It might have popped up that way, but if it didn't, go here. This is where we're going to change the tolerance. Typically 2 digits of precision aren't enough. We usually use 3. So under primary unit, this first drop down list, click the 3 digits of precision, which should be the 4th item down.
1, 2, 3.
Yeah, 3.123 is what it will show.
Mm.
Basically that just means 3 digits of precision. Then click OK. Now, I want to add another view to this. Now we're just going to add the plate. Now we're going to delete this view in a bit, but we're going to add it because I need to show you guys some stuff. So let's go back to place views. Let's go to base. Browse for a file. Go to your completed Gearbox folder and go to SC18W6001.
Can you add large icons so we can see the picture?
Wait, is it that one? Yeah. I didn't name mine.
Yeah, if you guys modeled it yourself, you'll name it
Mine's
something
named
different.
SR18CCGB.
Right, that's what I named it in the video. Yeah, I named it something different. What? All right, everybody got this plate selected?
Yes.
Click open. We just want a front view, maybe 0.75 on the scale. Want this middle option for the visual style? Just click OK. Now normally you wouldn't put 2 files in this, in a drawing like this. You wouldn't normally put a part and an assembly in a file. You'd use just one, but we're just messing around. So don't ever do this. But for our cases, this will be okay.
Do a titanium.
Okay, so dimension, let's go back to annotate. Everybody got this in their drawing?
Oh, well,
Yeah.
I put the wrong one.
No.
Yeah.
Oh, got it.
So look. It's the same one.
So you're just changing the scale. So just type in 0.75.
Well, that's called
Yeah.
240p.
Or 3/4.
Look, this is
It's 3 divided by 4.
Okay.
That's 3.
Everybody got it?
Yeah.
It's because you don't have the
Right. When I ask that question, if you don't got it, I expect you to tell me verbally that you don't got it.
I
You have it. Everybody has it. If I don't hear a no, I'm gonna move on. So, all right. So go back to the dimension tool. We're just gonna dimension the radius of these corner arcs, right? Because we need to know what radius this is in a lot of cases. So zoom. You'll have to zoom in, but zoom in. Click on the arc, and then you can place the dimension wherever you want. Creating drawings is complicated, and it's very, very detail oriented. It's very, very visual. The idea, you're not designing something. When you're creating a drawing, you're not designing something. You're creating a document. You're documenting your work. Okay? Yes, Ben.
What else did you click on?
I clicked on dimension, and then I just zoomed in and clicked on the arc.
Yeah, mine's not.
Because mine's not doing it.
That's, I think, but,
Oh,
I got it.
You don't click on the don't.
Well, when you
don't
click on
the
a
dot.
box.
Oh yeah, don't click on the green dot, click on the arc itself.
Oh, I hit F1.
Oh!
Where's the arc at?
Go get it.
It's so
Go get it.
I like you full
Okay,
of
so
monkeys.
when you're creating a drawing, your objective is to make it look really nice. You don't want to have dimensions off the sheet. You don't want to have dimensions with weird spacings. You don't want to have annotations on top of each other. You want to make it look really nice. Okay? So place this dimension up in the corner, make it look nice. Click to place it. Make it look nice, make it pretty. Because trust
Can I
me,
take a guess?
yes,
Are we gonna change it to 3.123?
yes you are. You're job.
So
Change
there's
change the precision to 3 digits, just like we did before.
Top one.
Okay.
Yep, top one. Click the drop down. Go to 3 digits of precision. Click on that. Then click OK when you're done.
I hit X, how do I get that screen?
Selection tool.
Oh.
Can you tell me how
Oh, there it is.
Okay, so dimensions work pretty much how you'd expect. You can also do angle dimensions if you want. But don't bother with that. Mess around with this on your own time, get used to it. Okay, so next, you guys remember how I've been telling you guys don't extrude circles, use the hole feature? You guys remember how I've been telling you that over and over and over and over again? Right, what I'm about to show you is the reason why. Because it makes making drawings way easier. So under the Annotate tab, there's this feature called Hole and Thread.
I see that.
Basically, holes on prints, there's a lot of international standards that govern how prints are supposed to look. Like, the way things look here are going to look pretty much the same regardless of what CAD system you're using. So all the symbols and the notations and the size, the shapes of all the arrows, it's all governed by standards. Holes have special notations that anybody that looks at a print is going to understand. So that's what the hole and thread feature is it's a special notes for holes. So click on that. And we've got a few holes. We're going to focus on these corner ones. So click on the hole and move the annotation out somewhere and click again to place it down. Now, it's not going to pop up a dialog. You'll just click and place it down and that'll be it. So
Wait, why is it down?
does it say through?
Yeah.
Yeah, that's fine. Actually, that's preferable.
0.25 and it says, it's that little circle the whole through at 0.25
Well, you modeled it wrong then.
Oh, I meant to click the wrong.
Oh, did you click this?
Wait, possibly.
Yeah.
Actually, why is mine not saying through? Mine should be saying through.
I can't get it not to say something. What do I click?
I mean, you want it to say through. It should be through.
It's
Oh,
saying-
right.
0.25
Right. So you guys remember how I was telling you guys to use a hole feature?
Yes.
You want to know what I didn't do on this file?
What?
It didn't use the hole feature.
I see the whole feature.
No.
Oh my god,
Well, if you use the whole feature like you should, it will do what Ben's did, and it'll tell you like through. If you had selected through all of the
I
hole.
selected the wrong one.
Wait.
Yeah, you got it, yes.
Anyways,
I selected the wrong one, but I looked like that.
if you escape out of that feature, yes.
It's not wrong. It's right.
Wait.
Mine doesn't have like the
So what do
arrows
we do
and
if we have a whole
1.5.
feature?
What? I'll show you guys here in a second. What's that?
It's just there.
Oh, you just use the dimension. Hit escape. Just select that. You gotta hit escape. You gotta get out of the dimension.
I was like,
Actually,
what does it say?
Now select it. Leave it. Go to hole. Alright, so if you were an idiot like me, you didn't model it right.
And we followed the video.
Hit escape to get out of the hole and thread tool.
Do we get a license?
Okay.
Double click on your whole annotation. Now, you can change the annotation here. And down here, there are these different buttons that will insert automatically different symbols. So select everything from the down arrow over. Right? And just type in what?
Yours is correct.
Because you're saying, if yours says through, then no, you don't. So type in capital THRU space, and then for those of you who already say through, you'll pick up right where what I'm about to do. And I don't know if this will work. Actually, no, it won't work. Never mind. Don't do that. Go to precision and tolerance,
It actually works. Oh, we just didn't change the number.
and then click on you uncheck use global precision, then under primary, change it to 3 digits.
Where's the precision in the top?
You've got to be editing the whole note. It's this button right here, Ben.
No, you don't.
Oh.
What button?
This button right here where my mouse is. On this edit whole dialog.
Uncheck that.
So right here, guys, click on this. You'll uncheck use global precision, and you'll change it to 3 digits.
Just the top one?
Just, yes. All right, click OK. You'll notice you got 3 digits of precision, and it says through.
Yours is wrong. Yeah. Yours is wrong.
Go line. You said not to do it, right? If it's correct.
Does yours already say this? You should change.
It doesn't say, it only says it's 0.25.
Oh, okay. Well, then you should do it.
It says through.
Oh, it does. Oh, it's a point 0.25 though.
Just double click it and then you have to go to the.
Is it? Are you doing this corner?
Oh, there.
X out.
You move your hand again. No, it's cool. Double, remove that arrow and then you keep E and.
Okay. When you modeled that.
Backspace.
Is this the file I gave you for?
Yeah.
Yes, got it.
You clicked the wrong thing, didn't you?
No, I didn't.
Wait.
I'm confused. I mean, it doesn't matter. It hurt anything. It's just modeled wrong.
Hey Ryan, do you have your daily steps in?
What? No, I don't. That'd be more.
So that's okay.
Okay, you're just. You should edit that.
Do it, that's okay.
And then go do it again. And then put a space
Hey.
between.
Okay. Control S. Should I save so just in case I crash something?
Most likely.
Alright. Dude, don't mess with my monitor. That is. I have triple monitor set up.
All right, everybody got a whole note that has 3 digits of precision and says through. All right. Now, guess what we're going to do next?
We're gonna select something else.
Select the view and delete it, and click OK.
Why you disappeared?
Yeah. We need to, we're gonna put a big table here, so it needs to be out of the way. Just select the view and delete it. You might have to. So you guys
Delete.
don't click. You don't want to click on the actual like lines. You want to click kind of in this white space.
Okay.
It's gone.
All right. If you need to move one of these views, you can, but you've got to click on the edge. See this dotted line? You've got to click like near the dotted line and click and drag to move these. But you're gonna want your part over to the left. Okay, so for assemblies, for drawings, so typically what you do is for parts, right? For parts, you're going to create drawings that give dimensions, that tell the locations and the sizes of holes, right? Does that make sense? So for every part that you're going to be manufacturing, right? If you're purchasing a part, you don't need to create a drawing. Okay, if you're buying a part off the shelf, like the motor, right? We wouldn't create a drawing for the motor. The company that manufactures the motor has already created a drawing, and we can go download it if we want. Vex has all the drawings for their components available, so you can go and download drawings if you want. But for every part that we're going to make, we're gonna create a drawing for it, right? And we're going to put all the dimensions, all the holes, all the threads, all of that stuff is going to be in a drawing for the part. For the assembly is going to tell us what parts are in the assembly, how many there are, and where they are. Okay? So we need to create what's called a parts list. Sometimes it's also called a bill of materials, or a BOM, a BOM. So if you hear somebody talking about a bomb, might not be the explosive kind of bomb, it might be the bill of materials for an assembly. Or it might be an explosive, you never know. You might want to check just in case. But if they're talking about a drawing and they say bomb, that's what they're talking about, the bill of materials. Alright. So basically if we go to annotate, over here there's a button called parts list. Click on that. Next, you need to select the file that the parts list will be extracted from. So you just click on your view. Just any, it doesn't matter, just one of them. So just click on one of them, then click, okay, everybody got that?
Yeah.
Yeah.
Click OK.
Okay.
Now you should have a rectangle following your mouse around.
Oh, hey.
Basically, you can
I
snap.
got an error.
Yeah, should I just okay it?
Mine's good.
I got an error.
What is it?
The bomb view is disabled in reference.
Oh, yes, you're always going to get that.
I didn't get it.
Okay.
Now I do.
Right. If you get that, the view is disabled, you're always going to get that the first time you place a parts list in an assembly. Okay, so the parts list will snap to corners of the border, which is what you want. So snap it up here in the top right-hand corner and click.
Whoa.
Top right-hand corner is the typical location for a parts list.
Mine is so much bigger.
Oh my gosh.
Is it like a Word document that we can make it smaller?
No.
Yeah.
Bro, grab the edges.
You can delete one. You can click on it and delete it if you place two. All right. So this is a list, guys. All right. So you see the columns up the top?
Yeah.
We got item numbers 1 through 19. Some of you guys might be 1 through 18 because I deleted the motor out of a few of yours.
Mine comes through 13.
Then you've got this item here, QTY, which is short for quantity. This is the number of that part in the assembly. You've got part number, which by default will be the file name, but you can change the part number. Yes, Ben?
I got 13.
That's fine. Oh, you did do the fasteners.
Oh, and then-
Yeah, so that's, yeah. And then over here you got the description, which you can fill in as well. You fill all this information out by editing the I properties in the part. You guys remember us going to the I properties to change like the weight and update the weight
Yep.
and stuff?
No.
No? You go to the I properties, you can change part number and description manually.
Oh, okay, good.
Okay.
All right, so you can right click and change the width of these columns, right? Now you'll notice under our description, a number of these cells are going to 2 lines because they're too long. But we need to fix that because our parts list is too long and it's extending down here and it's running into our title block, which is bad. So first of all, right, well if you guys don't have 19 parts, it won't be, but. All right, so item and quantity.
Oh, no, no.
Did you guys resize your drawing to be a
Why
nice
is
size?
not doing that? What?
Oh, I just figured out.
No, he doesn't have a motor, so he just has it all the way to the left, and it's working.
Yeah,
That's why it's
But-
I'll show you how to fix that.
yeah, I had 19 parts.
Okay. All right, you guys good? All right, so you can resize. Yeah, Gavin, you did this. Just grab this line, click and drag it all the way to the top to make it as small as it can be. All right, but we're more interested in resizing the columns. So make item.
It's still long.
Yeah.
It's still,
It's still out.
Okay, we'll fix that here in a second. So make item and quantity as narrow as they can be, right? Just squeeze them all as small as they can by clicking and dragging on the vertical lines. Go into, you see this little double arrow symbol that my mouse has? When you see that symbol, then you can click and drag. If you see the cursor, clicking and dragging is not going to do anything. You want to get the double arrow cursor.
why is your description so different?
Because I filled some of these in manually.
Mine just says step A, step B, A, B,
Yes, yeah, most of yours is gonna, the ones that you guys modeled aren't gonna have anything, and I went in and filled all these descriptions out myself. So all of these part numbers and stuff I filled in manually when I made this. And I haven't showed you guys how to do that, and I didn't have you guys do that, so,
Mine's perfect, thank you.
yeah.
That sounds like a lot of time.
Yeah, I mean, it's fairly time consuming. It's worth it, but it's fairly time consuming. So, alright, so make item and quantity as small as they can be. Did you guys all get that? Now make description big enough that all of the part numbers or all of the descriptions run to one line.
Oh, wow. Oh.
and then make part number. Make part number just the size of the part numbers. Make the description just the size of descriptions, right? Fit it so it fits. And all of a sudden you can see the table looks a lot nicer. It takes up a lot less space.
I don't know.
Maybe all right.
Mine's perfect.
Oh, man.
I got it. Oh, it's working.
Nice. Make your part number column a little bit wider. Zoom in, it would be easier to do.
Link in the description.
Alright, and then click and drag the line. Luke, you'll want to make your parts number column a little wider. Oh. You have some really, really long part numbers.
Ben broke the monitor.
No, Brett did it.
Okay, because you actually went through and named
No, that creep on your
them. What?
screen. The creep on your phone screen did it.
Yeah. that's
I got a picture on my phone.
Well, I'm actually going to show you how to solve that problem here. in a
Alright.
second.
You don't have to get it all of it, by the way. You
Creepers.
go down to the bottom. Click on
Okay.
it, it'll be not.
Yeah.
Alright, so there's one more thing. I'm going to show you how to do one more thing with parts lists that you may or may not do very often, but I'm going to show you how to do it anyways. If you want to split, I know that the engineers at my company do this a lot because we have got like 100 parts in each assembly and the parts lists are super huge and we have to like break them up. If you right click on an item in the list and go to table and click split table, it'll split the parts list into 2 parts and then you can go and put this parts list like somewhere else. Now, this drawing is a little small to be doing that.
I don't even do it for table.
And then if you want to undo that, you can right click and go to table and unsplit table.
Crap, how do I?
So right click on a item in the table, right click, table, split item,
That's actually pretty nice.
or split table.
Oh, I can't do that. It says it's too
That's
small.
all my screws you got.
Oh, did you click on the top?
I clicked the number
Screw.
3.
It'd be pretty hard to be discreet about that.
Yeah, you have to click somewhere in the middle.
Ben, quit breaking your mom.
Okay, we've only got a couple minutes here left here, guys. So let's guys, please don't break the computers in here. Stop messing with it. Just leave it the way it is.
Yeah, man.
The Kyoto Center is allowing us to use their space free of charge. Let's treat their stuff nicely. Okay, now we're going to show you guys how to use balloons. Then you asked about this earlier.
Well, I just drag, right click and then drag up and balloon.
But we're gonna show you how to use them. So basically, we've got an item number here, right?
I'm not using these.
Right, we've got an item number here that's telling us the number in this list. So we can place a little balloon that points to a part that tells us what number it is in this list. So go up here to the Annotate tab, go to Balloon, click on Balloon. Now click on a part. So you want to click where you want the balloon to attach. So you got to click on one of the lines. I want it to attach like right about here. So I'm going to click. I'm going to move the balloon out. And once again, you want it to look nice. Don't be crossing lines. Don't be crossing lines of balloons and stuff. You want to make them look nice. Okay, so move the balloon out somewhere around here. Click again, and then right click and click continue. Yes. I'm not sure.
So why did mine say
Pan up a little bit.
It's broken your computer.
No, because,
Middle.
you click on item number
12.
Click.
I
It's just your inventor's doing something weird. It's not wanting to load the full view. I'm not sure how to fix it. There's not a good. I mean, it's a fairly common problem that you run into.
Wait, I got a question. Mine flipped upside down behind the red.
What?
My number 12 flipped upside down.
Wow, that's so neat.
As soon as I hit continue. Yeah, that.
Oh, that's because you didn't click. So you click.
Well, I clicked and then it the other line went out, like around. Yeah, I'm doing.
Yeah, you did that, Ben.
Yeah, how do we?
Yeah, so Ben, here's what you did. Click, right click, continue.
Yeah.
You need to click, right click, continue. Alright, does everybody have a balloon on their screen that looks like mine?
Yes.
The number might be different because you might have a different number of points.
Oh.
Alright, you can create multiple balloons, right? So click something, place it down, right click, continue. Click something, place it down, right click, continue. Click something, place it down, right click, continue. Now this is important because next week we're gonna be taking this gearbox, we're gonna be exploding it out, and we're gonna make a drawing. If I can find it here. We're gonna make a drawing that looks like this. Okay? With a parts list. Yes.
Why do you have to continue?
Because whoever programmed it was kind of dumb. Well, actually, that's not really a good answer to your question, Gavin. This is the real reason. Because you can create balloons. You can create balloons that have more than one joint in the leader, so you can do this, right? You can click more than once. Now, typically, I do not like it when you do balloons like this, but every once in a while you can't avoid it. But yeah, so you can, I mean, you can, right? I mean, you can do all kinds of crazy things.
Wait, do you need?
I want to hear less clicking going on right now.
Wow, that was cool.
No. Yeah, that's exactly why you wouldn't do that. Well, that's the big reason I don't like doing this. If you can do a balloon with 1 leader line, only use 1 leader line. Now, there's a lot of other features here, guys. There are bend notes. You can use leader text, where you can click on something, and you can do the same thing as like a balloon, except you can type in text and place text. There's a whole lot of stuff here, but it takes a lot of time. We don't have time, we're out of time. So experiment with this, create a drawing, take apart your model, create a drawing for it, send me a picture.
What do we save this as?
Wait, where's that?
Make drawings.
Is that a hello world?
Wait, we don't need to save this, right?
No, you don't need to.
Oh, no, you get drawings.
I mean, you can if you want.
I saved this for an example.
There you go.
How do I change what it says?
Wait, we don't have to save this?
You don't have to if you don't.
How do I make mine say?
So, Ben, leader text, leader text, just like a balloon. Click on something, click, right click, continue, and then type the text. Okay. All right, that's all the time we've got for tonight. Good job, guys. Remember, next week is Labor Day. No CAD class next Sunday.
Good, because I'm going to be at a first birthday party.
Good.